This video will be all about exponents. So for this I have combined sections 13.2 and 13.5 into one, since it all seems to flow together, in my opinion. So we have, in order to have an exponent, you need to have a base. Okay, so the base is whatever the exponent is applied to. So that would be, your base would be like a normal sized text, and then your exponent is a smaller, would be like a smaller size text, and it's, you know, it's a superscript, so it's raised up. Whereas your, whatever your base is like on the same line, you know, as your other text. Okay, also known as, the exponent is also sometimes referred to as a power. All right, so when we have, if we want to write using exponential notation, so x times x times x, that would be written as x to the third power. Okay, and that's, in this x to the third power is also sometimes described as x cubed. All right, so that's all they're looking for on that. All right, and then number 2 says 5 times 5 times 5 times 5. So again, here all they're looking for is for you to write that using exponential notation. They don't want you to actually multiply that out. What they want, so since there's 4 5s, they're just looking for you to write that as 5 to the power of 4. Okay. All right, and then on number 3, we have -6 times -6. So again, and it's tempting to just give an answer, but what they're looking for is to write it using exponential notation. So we would keep the -6 in parentheses, and then -6 squared is what they're asking for on that. Number 4, 3/5. All right, so let's see how many of those do we have. 1, 2, 3, 4, 5. Okay, we have 5 of those, so we would write that 3/5 in parentheses raised to the power of 5. All right, so now we have written those using the exponential notation. All right, now when it says evaluate, that is where they're looking for the answer, you know, of actually multiplying it out. All right, so when you have a negative that is raised to an even power, the answer is going to be positive. A negative raised to an odd power is going to be negative. All right, and we'll see some examples of that. All right, so even, meaning even numbers like 2, 4, 6, 8, etc. And then odd numbers would be like 3, 5, 7, 9, etc. All right, so 2 to the power of 3. Okay, so that means 2 times 2 times 2. And then let's actually multiply those. So 2 times 2 is 4, and then 4 times 2 is 8. All right. And then number 6, we have -3 squared. All right, so that would be -3 times -3. And a negative times a negative is a positive, so that's going to be +9. All right, and that goes along with this, what we stated right here, which says it's a negative number, -3, raised to an even power. So 2 is an even number. So we had a negative, it was raised to an even exponent, and we got the answer is 9, +9. Okay. All right. So number 7, we have 1/3 raised to the power of 4. So we're going to do 1/3, and we're going to do it 4 times. So 1/3 times 1/3 times 1/3 times 1/3. All right, so we can just multiply across the top. So 1 times 1 times 1 times 1 is equal to 1. Okay, and then 3 times 3 is 9, and 3 times 3 is 9, and 9 times 9 is 81. So 1 over 81 is the answer for that. All right, and number 8, we have -4 raised to the power of 3. So -4 times -4 times -4. Okay, so -4 times -4 would equal +16. And then +16 multiplied by -4. So a negative times a negative gave us a positive right here. But then a positive times a negative is going to give us a negative answer. Okay. And then 16 times 4 is going to equal 64. All right, so -64 is the final answer. And again, we can see that that goes along with this right up here, which says a negative raised to an odd power is negative. So we had a negative number, which was -4, raised to an odd power. So the power is 3. 3 is an odd number, and so you can see that came out to be a negative answer. Okay. All right. So number 9. All right, so here we have this tricky problem again. We've seen a problem like this in a previous chapter. So you can see that here the negative is not inside parentheses, whereas like on number 6 and number 8, the negative was inside the parentheses. And so the exponent applied to that whole thing that's in the parentheses. So in this case, the exponent is not being applied to -2, it's only being applied to 2. So for clarification, you could write parentheses like this. Okay, and that's what it's really telling you. So there's just a single negative sign out here. Okay, so it's almost basically the same thing as saying like -1 multiplied by 2 to the 4th power. Okay, so we would do 2 to the 4th power first, and then whatever that answer is going to just become negative, basically. Okay, so, or you could say negative, and then parentheses, 2 times 2 times 2 times 2. All right, so 2 times 2 is 4, 4 times 2 is 8, and then 8 times 2 is 16. All right, so that's 16, and then just bring down that negative. So the final answer in this case is -16. All right, so again, this was not a negative number raised to an exponent. This was actually just a positive number raised to an exponent with a negative sign out here. Okay. All right. So number 10, then clearly we have the negative sign out here, and then 1/2 is raised to the power of 3. So there's just, again, a single negative sign, and then 1/2 times 1/2 times 1/2. All right, so bring down that negative sign, and then 1 times 1 times 1 is equal to 1, and then 2 times 2 is 4, 4 times 2 is 8. So -1/8 is the final answer on there. Okay. All right. Next, we will move on to our rules of exponents. Okay. All right. So again, with the terminology there, we're showing the numerical coefficient, the bases, and the exponents. All right. And so we have a couple questions on here, just pretty much asking us to identify the numerical coefficient, the bases, and the exponents. So let me just cover those right now, and then we'll go back and go over the rules. So on number 1, the numerical coefficient is -8. The bases are X and Y. And then the exponents are 5 and 2. Okay, and then on number 2, the numerical coefficient would be an invisible 1. The bases are a and b. And the exponent, another invisible 1 there, and then the 2. Okay, so number 3 is referring, so this problem number 3 right here is referring to rule number 5 there, which says that x to the power of 0 is equal to 1, all right? So, and that x could be anything, so regardless of what the base is, if you raise anything to the power of 0, it's equal to 1. So, on question number 3 right here, we have, if you have 3x in parentheses and it's raised to the power of 0, so that whole thing is raised to the power of 0, then your answer is going to be 1. However, the number on part A of that question, 3x to the 0 without any parentheses. So because there's no parentheses, we know that the power of 0 only applies to the x. It doesn't apply to 3x. So x to the 0 is 1, but then that is multiplied by the 3 still. So that's like 3 times 1, which then just equals 3. All right. All right. Now the next 3 problems are referring to rule number 1 up here, which is telling you that if you've got 2 things that have the same base and you multiply them, you can simplify that by adding the exponents. So x to the a times x to the b is equal to x to the power of a plus b. All right, so on your homework, you might see that referred to as like the product rule for exponents or something like that. Okay. All right, so the easiest one here actually I think is number 6. Let's look at that first. So a to the power of 8 times a to the power of 12. So that would be a to the power of 8 plus 12. And then we can simplify that because we know that 8 plus 12 is equal to 20. So your answer there would be a to the power of 20. All right, and then on these 2 problems here, they're not asking you to evaluate it. That would be a little bit ridiculous. They're just wanting you to simplify it by adding the exponents. So on number 4, we have 4 to the power of 3 times 4 to the power of 5. So that turns into 4 to the power of 8. Okay, and that's all they're looking for on that. And then on number 5, you've got 6 to the power of 5 times 6 to the power of 8. So 5 plus 8 is 13, so that simplifies to be 6 to the power of 13. All right, let's see, keep this page handy with my rules on it. Go to the next page, number 7. Okay, so we're going to multiply the numerical coefficients. So 6 times negative 9 equals negative 54. And then for the x's, we're going to add those exponents. So 2 plus 3 is equal to 5. So our answer is negative 54 x to the 5th. Number 8, we have negative 4 times negative 3 would equal positive 12. And then for the x's, so if the exponent isn't shown, we know that there's an invisible 1 there. So then 2 plus 1 is 3. So 12x to the 3rd power is the answer. Number 9, 4 times 8 is 32, whoops, I almost added instead of multiplied, oopsie. Okay, and then for the a, there's an invisible exponent of 1 on each of those. So 1 plus 1 is 2. Or in other words, a times a is a squared. Okay, then b, there's an invisible exponent of 1 there. And then 1 plus 5 equals 6. So that's b to the power of 6. So 32a squared b to the power of 6. Number 10. So in this case, we've got to multiply 2.3 times negative 3.5. All right, so a little bit of a review on what we did with multiplying of decimals in the previous chapter, or I guess a few chapters ago. All right, so I know it's a positive times a negative, so I know my answer is going to be negative. 2.3 times 3.5. 5 times 3 is 15. Carry the 1. 5 times 2 is 10. Plus 1 is 11. And then 3 times 3 is 9. And 3 times 2 is 6. So 5, that's 10. Carry the 1. That's 8. And then we need 2 digits after our decimal point, so that gives me negative 8.05. All right, and then we have a w. There's no other w to multiply it with, so we're just going to bring that over. And then for the x, we have x to the 4th times x, which has an invisible power of 1, and then 4 plus 1 is 5, so that's x to the 5th power. And then we have y to the 4th power with no other y's to combine it with, so just bring that over. Okie dokie, so negative 8.05, wx to the 5th, y to the 4th. That's my final answer there. All right, number 11, that's a little tricky one because it's everything's multiplied by 0 ultimately, so anything multiplied by 0 equals 0. All right, and then number 12, so 3 times 5 is 15. 15 times negative 2 would equal negative 30. Okay, then let's look at the a's. So just have a to the 1 times a squared. So 1 plus 2 is 3. So that's going to be a to the 3rd power. And then for b, there's b to the 1. This one doesn't have a b. This one has b squared. So 1 plus 2 is 3. So that's b to the 3rd power. And then we have c to the power of 1, c to the power of 3, 1 plus 3 is 4, so c to the 4th power. Okay, so my final answer for that is negative 30, a cubed, b cubed, c to the 4th power. Alrighty. Okay, next we're going to look at what to do with negative exponents. Okie dokie. So, let's see. All right, so looking back at our rules here, rule number 7, x to the power of negative n equals 1 over x to the power of n. Okay, so if you have a negative exponent, that means you want to do the reciprocal to get rid of that negative. Okay, so in other words, assuming it's not already in the denominator, you would move it to the denominator, or vice versa. Okay, so if x to the negative n equals 1 over x to the n, all right, then y to the power of negative 5 equals 1 over y to the power of 5. All right, so in this class, we're always going to be wanting to get rid of the negative in the exponent. All right, only positive exponents. So now on number 14, we have 1 over z to the power of negative 10. So since that, you're just going to do the reciprocal, okay? You're going to flip it over. All right, so that's actually going to become just z to the power of positive 10 then. All right, and number 15, all of those have negative exponents, so I'm just going to basically flip the whole fraction, and then that will just get rid of all the negatives. So that would give me z to the 5th over x to the 6th y squared. All right. Let's see, number 16. All right, so one of our variables has a negative exponent, so the one that has the negative exponent is just going to move to the denominator. All right, so a to the 5th is going to be the numerator, and then b to the 8th is the denominator. So basically we took this and we put it under there, and that got rid of the negative in the exponent. Number 17. I don't know why I never give myself more space for that problem. It really needs a little bit more space. All right, well, we have something in parentheses with a negative exponent on the outside. So we could start by basically just putting the whole thing underneath a 1. And what that will do is it will get rid of this negative sign right here. But what's in the parentheses will remain exactly the same, including that negative sign, okay? All right, so it'll be 4x to the negative 4, and all of that is squared. Okay. All right, so next we kind of need to look at another one of our rules, rule number 4, which basically is telling us that we can distribute an exponent. So if the stuff that we have inside the parentheses is just a single term, meaning like, you've got variables that are like multiplying or dividing with each other, not adding or subtracting, but just multiplying or dividing, then you can just distribute that exponent to each variable. Or it doesn't have to be a variable, it can also be a number. Okay, so that's kind of what we're going to do for number 17. Let's see. I need more space. Sorry, number 19. I'm going to take this space. All right, so still has a 1 on top. Okay, so 4 squared is 16. All right, and then next we're going to multiply these exponents. That's another one of our rules, is that if you have an exponent raised to another exponent, you multiply the exponents. So negative 4 multiplied by 2 equals negative 8. So it's going to be x to the negative 8. Okay. Now we still want to get rid of the negative exponent. So since that's on the denominator now, we're going to move that up to the numerator. So we're just going to take this, we're going to move it up here, and that's going to get rid of the negative. Okay. So it'll basically be like 1 times x to the negative 8. But when you multiply it by 1, that doesn't really do anything. So it's just going to be x to the power of 8 over 16. So the 16 just stayed there. So that's my final answer for number 17. Okay. All right, let's go ahead and look at number 19 there. So that's an easy one. Basically, all we need to do is just take that part that has the negative exponent and just move it down underneath the other part. So it's going to end up being 4 over y to the 4th. And that's it. All right, so our goal is just getting rid of the negative exponent. All right. Number 18. So we have 4 to the power of negative 1 plus 4 to the power, plus 5 to the power of negative 1. So to get rid of those negative exponents, that would just be 1 over 4 to the power of positive 1, which is the same thing as just 1 over 4. And then 5 to the power of negative 1 is just 1 over 5. All right, so now it's just a matter of adding fractions. So personally, I like to just use the bow tie method, which means I would do 5 times 1 is 5, plus 4 times 1 is 4, all over, and then 4 times 5 is 20. So I've got 5 plus 4 over 20, and then I know that 5 plus 4 is 9, so 9 over 20 is the final answer for that. Okay. All right, so number 20, I have negative 3 raised to the power of negative 2. All right, so I want to get rid of the negative in the exponent, so I will put a 1 over it. So it would be 1 over, okay, now all we're doing is we're getting rid of that negative sign. So the part that's in the parentheses stays the same. So it's 1 over negative 3 in parentheses raised to the power of 2. All right, well, negative 3 raised to the power of 2. So negative 3 times negative 3 equals positive 9. So this would be 1 over 9. All right, now what if we basically have something that looks just like that, only without the parentheses? Okay, well now the exponent doesn't apply to the negative. So it's, again, it's kind of like this. So we just have that negative hanging out in the front, okay? And then 3 to the power of negative 2, to get rid of the negative in the exponent, that would turn into 1 over 3 squared. All right, and then again, we still have that negative hanging out in the front, and then 3 squared is 9. So our final answer here is negative 1/9. All right. All right, let's see. Okay, I have to go ahead and cut this video, and then so this will be part A, and then I will go ahead to part B right after this.